In a unit with plenty of complicated things going on, here's one that's not so bad, which is the formula that relates S, which stands for arc length. I don't know why it's S, but it is. The arc length in a circle to the radius and a given angle. So in this example, I've drawn a circle with a radius of 3. And by our definition, or the definition of a radius, so if this is an arc length of 3, then that means that this is 1 radian. And if here's another 3, that means there's another radian. And we can pretty clearly see how these relate together. 1 radian means 1 radius of arc length along the outside. 2 radians means 2 radii of length along the outside. So in other words, the total arc length is however many radians you have times whatever the length of the radius is. So in this one, this would be the arc length equals the radius is 3. The angle is 2 radians. And sure enough, it's 6. So this formula really is as straightforward as it looks. It's basically just saying how many radii are you stretching along the outside of a circle? In other words, how many radians? And then how big is each radius? Multiply those things and you get the total arc length. So we can do a few questions this way. This first one, and we'll just use this circle with a radius of 3. This first one is saying, what is the arc length for an angle of pi over 6? So we'd say, okay, S equals R, radius is 3, times pi over 6. Do some canceling. That arc length would be pi over 2. And to be clear, this is in radians, so this is an angle, right? This is an arc length, so that's just how many inches or how many feet or whatever. So like 1.6-ish feet, right? But more accurately, pi over 2. Same kind of deal here. Same thing, we'll assume the radius is 3. So arc length equals the radius times the number of radians, 9 pi over 4. So whatever that is, that would be 27, somewhere between 5. No, I didn't do that right. Hang on a second. So that would be 27 over 4, no, about 7, give or take. I was just kidding when I said 5. And we can also kind of do this, I don't know, not backwards. This is just like any formula. You plug in the parts you know and you solve for whatever you don't. So if the arc length is 4.5 and the radius is 3, then we can solve for the angle. And we would divide by 3 on both sides. So the angle would equal, so that would be 1.5 radians. Again, radians, no symbol. We would just say theta equals 1.5. So pretty simple formula. We use it to relate arc length, radius, and the central angle in a circle. In fact, we could even do one more version where, and I'll put this up here. You can even do one more version where I say, if an angle of 7 pi over 6, I can't make the pi symbol on here, at least not easily. If an angle of 7 pi over 6 in a circle has an arc length of 6, what is the radius? Radius of the circle. Same thing, we use the same formula, we plug in what we know and we solve for what we don't. So let's see, we know the arc length equals, we don't know the radius, we do know theta. To get r by itself, we would multiply by the reciprocal of this on both sides. I'll do that in a different color here. And we get r equals, nothing cancels there, so 36 over 7 pi, and that would be our answer. It's all the same formula. We plug in what we know, we solve for what we don't.